Dear students, today we'll be solving the IB Math EA HL November 2023 paper 1 question number 6. You will be getting the solved 5 questions, the first 5 questions of this paper in the playlist named IB Math EA HL November 2023 paper 1 in my channel NS Online Math Tutoring classes. You will be getting all the other solved questions, the past paper solved questions in form of playlist also in my channel, and from now onwards you will be getting the past paper solved questions grouped according to the topics also in form of playlist in my channel NS Online Math Tutoring classes. I'm Nilanjana Sanyal. I'm an online IB Math AHL tutor. In case you want to join my sessions, please contact me for more details. My phone number and my website link are given below. So without any further delay, let us start answering question number 6. The maximum mark is 7. It says, prove by mathematical induction that 5 raised to the power of 2n minus 2 raised to the power of 3n is divisible by 17 for all n belonging to the set of positive integers. And as we do, we take the smallest value of n and we check that for that particular value of n whether the expression is satisfied, in this case whether that expression is getting divided by 17. Okay, so the smallest positive integer is 1, therefore we will be taking the first value of n as 1. So when n equal to 1, 5 raised to the power of 2 times 1 minus 2 to the power of 3 times 1, which is 5 square minus 2 cube, that is 25 minus 8, which is equal to 17. So definitely 17 is divisible by 17. So I can write divisible by 17. And now I will be assuming that this is true for some value of n. I am taking that value to be equal to k. Okay. Let the given condition be true for n equal to k, and k belongs to the set of positive integers. K is a positive number, integer number. Okay. Therefore, 5 to the power of 2k minus 2 to the power of 3k is divisible by 17. Okay. And I have written this as a sentence but I want to make an equation, or I have to express this mathematically. How do I say the same thing mathematically? I will be saying this implies 5 to the power of 2k minus 2 to the power of 3k equal to, say, 17 times a. Okay, a is an integer. Only when you have, say, 17 times 1 or 17 times 2 or 17 times negative 1, 17 times positive 5, a is an integer only when you have an integer multiple of 17. Can you say 5 to the power of 2k minus 2 to the power of 3k is divisible by 17? Okay, so I am just writing a belongs to the set of integers. I am not specifying whether a is a positive integer or negative integer. Just I am saying that a is an integer because a should be an integer. Doesn't matter whether it is a positive integer or negative integer, which when multiplied by 17, if it is equal to 5 to the power of 2k minus 2 to the power of 3k expression, then we can say 5 to the power of 2k minus 2 to the power of 3k is divisible by 17. Okay, so this is true. Therefore, to prove when n equal to k plus 1, 5 to the power of 2 k plus 1 minus 2 to the power of 3k plus 1 is divisible by 17. Okay. So 5 to the power of 2k plus 1 and 2 to the power of 3k plus 1. So I can just expand the powers and I get that as 5 to the power of 2k plus 2 minus 2 to the power of 3k plus 3. And most of the students come to this up to this point and then they get stuck. Why should you be getting stuck? Because you know that this part has already been taken as true. So you have to first of all try to get this expression written in this format. Okay, so how can I do that? Let me write this as 5 square times 5 to the power of 2k. I just want to get as close as possible to this expression. It is 5 to the power of 2k, so I have separated 5 square just to get 5 to the power of 2k. Okay, and similarly 2 cube minus 2 cube times 2 to the power of 3k, which is equal to 5 square is 25 times 5 to the power of 2k minus 2 cube is 8, 8 times 2 to the power of 3k. Okay, and how can I get this expression 5 to the power of 2k minus 2 to the power of 3k? I am seeing that 8 is the coefficient of this part. So if I have the coefficient of 5 to the power of 2k as 8, I can take 8 as the common factor between the two terms, and within the bracket I'll be taking 8 outside, and within the bracket I'll be having 5 to the power of 2k minus 2 to the power of 3k, which I can say is divisible by 17. I have taken that to be true. Okay, so how can I get a coefficient of 8 for 5 to the power of 2k? I'm having the coefficient of 25. So let us write this 25 in this format. Because I need 8, so I am taking it 8. I need 8, so I have written 8. What remains from 25? If I take out 8, what number remains? 25 minus 8 is 17. Okay, so it is 8 plus 17 times 5 to the power of 2k minus 8 times 2 to the power of 3k is equal to, now I can write 8 times 5 to the power of 2k plus 17 times 5 to the power of 2k minus 8 times 2 to the power of 3k. Okay, so this is equal to, I'll be taking this term and this term because they are having this common coefficient 8. So 8 and 5 to the power of 2k minus 2 to the power of 3k. And this I know to be divisible by 17. Okay, and the only one term that is remaining is this 17 times 5 to the power of 2k. Obviously, because you are having a factor of 17 in this term, this will be divisible by 17. Okay, so this can be written as 8 times, in place of this I am writing 17a. Okay, so 17a plus 17 times 5 to the power of 2k. So this is divisible by 17 because for the first term it contains a factor of 17, and for the second term also we are seeing that the factor of 17 is present. So this whole expression is divisible by 17. Okay, so therefore the given condition is true for n equal to 1. It is true for n equal to k plus 1 whenever it is true for n equal to k k belonging to the set of positive integers. So it is true for n equal to k plus 1 whenever it is true for n equal to k. And we have proved that for n equal to 1 it is true. Therefore, for n equal to 1 plus 1, that is n equal to 2, it will also be true. If it is true for n equal to 2, for n equal to 2 plus 1, which is n equal to 3, it should be true. So this way it will be true for every positive integer. Okay. So therefore, by mathematical induction, we can say 5 to the power of 2n minus 2 to the power of 3n is divisible by 17, where n belongs to the set of positive integers. Okay. So this is the whole proof. Thank you for staying with me till the end. Please give this video a like in case you have liked this video, my explanation. And please share this video with your friends so that even they can get benefited by watching my video. And please subscribe to my YouTube channel. It will be motivating me to make more math videos for you. I'll be knowing that I am being able to help you, as well as it will be telling the YouTube that my videos are worth watching. So YouTube will be sharing my video to more number of students. So you will be helping me and you will also be helping other students by just subscribing and liking my video and also sharing my video. We meet again very soon in our next session. We will be solving the very next question of the same paper. So till then, bye.